All right, guys, we're going to be looking at some properties of rhombuses. All right, so just to go and review some of them. One thing that we want to pay attention to is diagonals of the rhombuses will bisect each other, and that is true for parallelograms in general. So you'll notice that these two sections of CA are congruent, as well as these two sections are congruent to each other. All sides of a rhombus are congruent. That's what makes them special for parallelograms, is that all of them are actually the same. So all of these, all the way around, gives it that diamond formation. A lot of people like to call it a diamond, but it is a rhombus. They are all congruent to each other. Diagonals will bisect the angles. And what that just simply means is that it bisects it, it cuts it in half. So these sets right there are congruent, cutting those in half, as well as these right here are bisected or cut in half. So there's a lot of drawing on that. Let's go ahead and just answer a couple of basic questions about that. So if I was to ask, well, what is the length of dB? So what is the measure of dB? Well, we know that dB is all the way across this diagonal right there. And one of the things we just said was that the diagonal is bisected. So this length right there is 5. That would mean that this is also 5 right there. So dB has a length of 5 plus 5. Nice and easy math right there, which is 10. Okay, if I was to ask for the perimeter of ABCD, of this rhombus ABCD, we know that all of the sides are equal to 9. So we just simply say, okay, well, it's 9 plus 9 plus 9 plus 9, or 9 times 4. And we know that 9 times 4 is simply 36 would be the total length all the way around. Now we do get into a little bit more complicated problems. And one of the properties that's in here is that diagonals are perpendicular to each other. So let me go ahead and erase some of this that's on here currently. Okay, and I want to identify that one piece right there, that diagonals are in fact perpendicular to each other on a parallelogram, or I'm sorry, on a rhombus. Okay, which means that they form a 90-degree angle. And what that does is it creates a special situation where we have a right triangle, or 4 right triangles that are set up. And those 4 right triangles are congruent to each other. So let's go ahead and find the length of CA. What is CA equal to? Okay, well, if I want to find CA, which is the length all the way down, what we need to do is we need to pay attention to the fact that we need to find CE first, okay? So let's go ahead and find CE. And the way we're going to find CE is to do the Pythagorean theorem. So what I'm going to do is I'm going to say, okay, well, we've got x squared plus 5 squared equals to 9 squared. And when we do that, I'm going to come over here. I'm going to say, well, x squared plus 25 equals to 81. I'm going to subtract the 25 over. And we're going to get x squared equals to 81 minus 25, which is going to be 56. Now, at this point, what we do is we take the square root. Okay, and when we take the square and the square root, they're going to cancel. And we're going to get x equals to the square root of 56. Now, depending on what we're looking for, we have 2 ways of getting this answer. We can get the approximate answer. We can go to Desmos and we can find the approximate answer. So we can find the square root of 56. 56, which is 7.48. Okay. Which is 7.48. Or we can break down this square root of 56. So I could take 56, which is going to be 2 times 28, 2 times 7, or I'm sorry, 2 times 14. Then we take 14, we get 2 times 7. And then what we can do is we can actually break that down. We say 2 times 2 times 2 times 7 take the square root. And then remember, when we're looking for the square root, we would have, we bring out the group of 2, and we get 2 times the square root of 14. And we could write our answer as a simplified radical 2 times the square root of 14. But that was not our question. So we could say x is equal to 7.48 or 2 times the square root of 14. But our question was, what is CA, the total length? Okay, so what are we going to do? We're going to double it. So I could take 7.48, multiply it by 2, or depending on what I'm asking for in terms of the question, I would just say 2 times the square root of 14, which is simple. It is 4 times the square root of 14. Or if we want to go over here and type everything into Desmos, I would say, okay, well, 2 times 2 times the square root of 14. And it will bring us to the exact same answer that we had before, which is approximately 14.96 or 2. And if we doubled the 7.48, that would also bring us to that same exact answer. Okay? So we would be roughly at 4 times the square root of 14, or like what we had said, 14.96. All right, I hope that helps you out with the rhombus problems that are out there. Y'all have a great day.